Hi everyone, Miss Wombold here, and thank you for checking in. I hope you're doing well. So today we're going to be doing an introduction to what are called conic sections. And when I say introduction, I mean like barely getting to know them at all today. We're going to focus on parabolas, circles, and ellipses or ellipses. They're so like I said, we're barely touching the surface here, and there's actually a fourth conic section called a hyperbola. Um, and when you get to pre-calculus, you'll learn all sorts of vocabulary and other ways to look at these, and it'll be really in depth. But today we're just thinking about what are these and how are they graphed. So the name conic section comes from the fact that all of these shapes can be created. If you imagine taking like a piece of paper, um, a, a thin plane, right, a piece of paper, and slicing it through a cone, you can form these shapes. If you slice perfectly parallel to the bottom, you get a nice circle. If you slice through the cone, you get an ellipse. If you slice from the side of the cone to the base of the cone, you can get a parabola. And if we actually had another cone on top of this opening upwards, we could use that to form what's called a hyperbola. But like I said, today we're only going to focus on these three shapes, circle, ellipse, and parabola, because I think that'll help you with your name graph. So parabola is actually familiar to us, right? It's our familiar conic section. And so the features that we know from vertex form of a parabola still apply here, right? We have our h and our k values. And so h and k tell us the vertex, really kind of where the graph is centered or where the parabola is centered. And then that a value can either make our graph wide or narrow, and it can make it open up or down, depending on whether A is positive or A is negative. So again, we think about uh, parabolas here. They can either open upwards if A is positive or downwards if A is negative, and then we always have that vertex right at either the minimum or the maximum at the point HK. You can also technically have parabolas that open to the side. Maybe I'll do a little example right here. If you switch the x and the y value, this would be like making a square root function, but actually getting both halves of it. But I'll leave that to you to explore. So if I were making my name graph and I needed, for instance, an A or the body of an A, and I know that I want it to be centered right here at 2, 4, and I want it to open downward, and maybe I want it to be kind of a wider parabola, right? I want it to be stretched out. Then I might be playing around with something that starts with negative 1/2, right? That negative will make it open downward. And then I need to think about what are my values of that vertex. Well, I've got an h of 2, so I'm going to put x minus 2 squared, right? And then a y value of my vertex of 4 and a k of 4 at the very end there. So again, if I'm making my name graph, I'm using these conic sections to kind of suit my needs here. If I need a parabola that opens downward and has a certain vertex, um, that vertex form can be really helpful here. So parabolas are somewhat familiar, but I want to see how we could also make circles or make an ellipse to suit our needs similarly. So a circle, right, is defined as having the same distance or a constant distance from a center point, and that constant distance is called a radius, right? Um, and so if we take a look at this equation of a circle, well, that radius is an important feature of the circle, and it's actually embedded in our equation. We use r squared there, but r is going to represent the radius. And then there are some other familiar faces here, one of which has a major typo. We have x minus h, right, which looks like the vertex form of our parabola. And then we should have y minus k. So go ahead and change that to a k there. That's my mistake there. It should say k. And h and k, just like they represent the vertex of a parabola, they represent the mid or the center of the circle. H and k represent the x and y coordinates of the center of our circle. So I'm just going to write that down here. Our center is at the coordinate point H and K. And again, that should be K because it's getting less and less clear to me. So how would I use this to make my name graph? Well, okay, so let's say I need an O, and I want my O to be centered at the point 3, 3, right? 3, 3. So I know that my equation is going to have something like x minus 3 squared and y minus 3 squared because those are my two x and my y coordinates. And then if I wanted, let's say, a radius of 2, and I want it to go all the way around, right? That's going to be a better circle on your graph, I'm sure. But if my radius is 2, then I can write this as 2 squared on the other side of the equal sign. And if I'm using Desmos and I want to play around with that, oh, maybe 2 isn't exactly the radius I want. Maybe I need a radius of 4. It's super easy to swap out that radius as needed. Maybe I decided, oh, I don't want it at 3, 3. I want it at 2, 3. So I could really, again, easily switch out my coordinate points as well and make this circle exactly where I want it to be. I can also use domain or range restrictions to change how my or to show only a part of my circle, right? If for instance I was making a circle, let's say with a radius of 2 again, oops, this time circled below the x-axis, but if I only wanted to show half of the circle, right, I only want to show that right-hand half, I could restrict the domain to be just between the x values that I want there. And if you watch my video about getting started with your name graph, I'll show you how to do that there as well. So one more shape we're going to look at is an ellipse. And so while a circle has a constant distance from a center point, an ellipse does not. It actually has, it's very interesting, and I'm excited for you for pre-calculus. It actually has a constant distance between 2 points. And if you think of this as like a string attached to two little posts, and you trace that string around and held it tight, it would actually form an ellipse. So that's something you could actually try at home if you look up how to make an ellipse with a string and two points there. But that's getting beside myself here. So the formula for an ellipse is somewhat similar. It has that x minus h and y minus k. And look, I even wrote it down correctly here. So h and k still tell us a center. And I'm going to call it that, a center at h and k. So those coordinate points still hold true. But you'll notice that on the right-hand side of the equal sign, it's not an r squared, it's not any number squared, it is 1, and it's always going to be 1 right there. And the two new additions that we have are a squared and b squared in the denominators here. And what a squared tells us, actually I'm going to pick this little thing up and move it just a bit. Nope. give myself a little bit of space. So what this A tells us is it tells us kind of the horizontal. I'm going to use the word radius in quotations. That is not the precise name for it, but I think it best fits with what we're familiar with as far as circle goes. Whereas the B value is kind of our vertical radius, again in quotes, because that's not the mathematical term for it. So if we think about it as our center value, H and K, right, we can have a horizontal distance to the edge there that would be a length of A, and a vertical distance that is a length of B. And it doesn't matter whether the ellipse is short and wide or tall and skinny, right? A and B are always going to tell us the vertical and the horizontal distance there from the center. So again, how might I use this to make my name graph? Well, for instance, in my last name, I needed the letter D, right? And when I saw the letter D, I saw that as maybe half of an ellipse. And so I want, let's say I want an ellipse that is centered at 0, 2. And I want it to be 4 units, or to have a horizontal distance of 4 units from the center. So I'm kind of tracing this out in my mind. I'm going to start, of course, with my center there. So if my center is 0, 2, then in my equation, I'm going to do x minus 0 squared and y minus 2 squared. And then I need to think about what am I going to be dividing by. Those are those distances squared. So if my horizontal distance is 4, I'm going to be dividing by 4 squared. And then let's say I want a vertical height or a vertical distance of 3. So I'm going to divide by 3 squared there and set it all equal to 1. And what that would do is it would form this ellipse very carefully there. Hope that end part got a little bit silly. Little bit off there, but I hope you get the idea. Something to be careful of is that those A and B values, right, are not the entire width of the ellipse there. So that entire width would be 8 units, but again, the radius, right, from the center to the edge horizontally is only 4, and same with that vertical distance there. If I needed to cut this off using a domain restriction, right? If I only wanted to show, let's see, I'm going to erase that. If I only wanted to show the right-hand side of this, again, if I was making the letter D or something like that, I could restrict that by saying, let's restrict X between 0 and 4, and it would cut off everything else. So I happen to find conic sections really fun to just kind of play around with. So I know, like I said, this was a very brief overview, and that was intentional. We did not cover everything else. If you were to Google search conic sections, you would find a whole slew of other information. But for today, I think we can just focus on kind of these key features, the vertex or the center, and kind of those horizontal and vertical distances from the center there. So you've got some questions to practice, but I also encourage you to go over to Desmos, play with the graphing calculator, and play with these shapes a bit. Like I said, they're surprisingly fun in the way that you can change things around and really make some interesting things. So thank you again for checking in. Stay well, take care of yourself. I miss you, and you're doing a great job. Let me know if you need anything.